Welcome everyone. In this video lecture, I'll discuss some properties of direct sum of subspaces. In my last lecture, I'll discuss two properties on direct sum of subspaces. Let's recall that. The first property was that if we are given some subspaces of finite dimensional vector space V, these are the subspaces. Okay, and this is a finite dimensional vector space. Then if V is equal to direct sum of these subspaces, then it will be equal to sum of these subspaces. I am not using direct term here. It is equal to simple sum of these subspaces. And if we take out one vector, each from subspace Wi, then V1, if we have the sum of these vectors is equal to 0, this V1 is taken from W1, V2 is taken from W2, and Vk is taken from Wk. If we have sum of these vectors is equal to 0, then each vector would be equal to 0. This indicates the unique representation of the vector 0. And second property was that if we are given this condition, that is, if V is equal to sum of the subspaces and this condition holds, then every vector can be uniquely written as sum of the vectors v1, v2 and vk, where vi is taken from wi. We are given this condition and this condition, then this condition holds good. This is a unique representation of the vector v in the vector space. Today we'll do the new property in the form of a theorem. So this property is that if each vector v of the vector space V can be uniquely written as sum of the vectors v1, v2, v3 and vk, where vi is taken from wi. Okay, if each vector has unique representation of this type, then also if suppose gamma I is an ordered basis, ordered basis का मतलब समझते हैं आप लोग? Ordered basis is a set of vectors that spans that vector space as well as linearly independent. So gamma I is a collection of vectors with the vectors which spans the subspace W1, Wi. Okay. So gamma 1 is an ordered basis for W1, gamma 2 is an ordered basis for W2 and so on. Okay, ordered basis for Wi, I varies from 1 to k. Then gamma 1 union gamma 2 union gamma k is an ordered basis for V. इसको समझने के लिए let's draw a diagram, जो एक फिगर ड्रॉ करते हैं. Suppose we have, this is a vector space, okay, V, and we have some subspaces of this vector space. We say this is W1, this is W2, this is W3, this is W4, W5, and suppose this is WK. Okay, so we are given that each vector has unique representation. Gamma I is an ordered basis for W1. Means gamma 1 is here, which is collection of some vectors. We don't know how many vectors are there in gamma 1. There may be one vector, there may be two vectors, or there may be three vectors. We don't know. This is gamma 1. Similarly, here we have some collection of vectors which is called gamma 2. Here we have gamma 3, gamma 4, gamma 5, and gamma k. So these are some vectors in the subspace W1, W2, W3, W4, W5, Wk. These vectors are they makes the set which is called gamma 1, and this is called an ordered basis for W1. Means these are the vectors which span W1, means their linear combination generates W1, and they are linearly independent. So the theorem says that, the property says that if we take the union of these vectors, then this makes the ordered basis for the vector space V. So we'll prove this. Okay. To prove this, first of all, we have to show that गामा, हमें ये प्रूफ करना है कि गामा 1, गामा 2, गामा k का यूनियन ऑर्डर्ड बेसिस होगा V के लिए. तो क्योंकि हमें ये गिवन है कि हर वेक्टर की रिप्रेजेंटेशन यूनिक है, तो V is direct sum of the subspaces W1, W2, and W3, right? So we write here, since each vector V belongs to V has unique representation so V is equal to direct sum of W1, W2, and Wk. Okay. क्योंकि ये प्रॉपर्टी होती है डायरेक्ट सम की. Okay. So we write here V is equal to sum of Wi. डायरेक्ट सम है तो sum of Wi की इक्वल तो हो गई. अब गामा 1 ऑर्डर्ड बेसिस है W1 के लिए, गामा 2 ऑर्डर्ड बेसिस है W2 के लिए. We have to prove that gamma 1 union gamma 2 union gamma k is an ordered basis for V. So we have to show that their union generates V first of all. We'll write, since gamma is are ordered basis for WIs. This implies that gamma 1 union gamma 2 union gamma k generates V. Okay. To show that gamma 1 union gamma 2 union gamma k is an ordered basis for V, we have to prove that all the vectors in gamma 1 union gamma 2 union gamma k are linearly independent. तो ये आपको सबसे पहले मैं क्लियर कर देती हूँ कि कैसे इनका यूनियन V को जनरेट कर रहा है। इसको मैं इलेबोरेट कर देती हूँ इस लाइन को। आपने लिखा V इज इक्वल टू W1 प्लस W2 प्लस WK। ओके, हम W1 को लिख सकते हैं समेशन AIJ mu IJ, J varies from 1 to M1 plus AIJ mu IJ, J varies from 1 to M2 summation AIJ mu IJ, J varies from 1 to Mi. यहाँ पर I varies from 1 to K है, and mu ij are the vectors in With subspace. Sorry, in gamma ith ordered basis. J varies from 1 to M I ले सकते हो आप। तो फर्स्ट वेक्टर में गामा 1 में वी हैव गामा 1 ऑर्डर्ड बेसिस में हमने जो वेक्टर सपोज किए हैं वो है mu11, mu12, mu1m1। ओके, ये नोटेशन है जस्ट to denote the vectors in the ordered basis gamma 1, which is the ordered basis of W1. So W1 is the span of these vectors, means their linear combination generates W. So that's why this is equal to summation Aij mu ij. Similarly, it is written for W2 and Wk. So this is nothing but you can write this like this: A11 mu11, A12 mu12, A1M1 mu1M1. This is the expanded form of this summation. Similarly, for this you can write A21 mu21, A22 mu22, A2M1 M2 mu 2M2. Okay, so last line would be A K1 mu K1, A K2 mu K2, A K M K mu K and K. Okay, and if I denote this sum by any of the element of the subspace W1, suppose that element is say W1, ये कोई भी एलिमेंट हो सकता है ये, मैंने randomly suppose W1 लिया है, then for second summation let it is W2, and for last one it is say Wk. So these Wi's are the member of subspaces, and indirectly they are also the members of vector space V, and they denote any of the member of subspace or vector space. So we can say that these vectors generates V also, these mu ij's. Okay, so you can write here, since Wi's belongs to V also, this implies that the vectors in gamma 1 union gamma 2 union gamma k generates V also. Now to prove that all the vectors in their union are linearly independent, let us consider um, now let summation Aij mu ij for all ij is equal to 0. Now all the linear combinations हमने 0 की इक्वल रख दी. अब हमें ये प्रूफ करना है सारे कांस्टेंट 0 की इक्वल है. तो we can write ये जो इक्वेशन आई है यहाँ पर, हमने यहाँ पर पार्शियल सम को W1 से डिनोट किया था, वही चीज हम कर रहे हैं जो हमने पहले किया था। ये सम W1 से डिनोट किया था। ओके, तो हम इसमें W1 प्लस W2 WK इज इक्वल टू 0 लिख सकते हैं। और W1 को हमने क्या लिखा है, समेशन Aij म्यू ij j वेरीज फ्रॉम 1 टू mi, यही है W1 की वैल्यू। W2 की वैल्यू है Aij म्यू ij j वेरीज फ्रॉम 1 टू m2, दिस इज m1। Aij म्यू ij j वेरीज फ्रॉम 1 टू mk, ओके, दिस इज इक्वल टू 0, क्योंकि wi इनके स्पैन में है। So W1 will be equal to the linear combination of these vectors, okay, where Wi is a member of subspace Wi. Now, since you can see that we are given that each of the vector in the vector space V has unique representation. Okay, so when the uh, sum of the vectors is coming out to be 0, that means each of the vector will be equal to 0. Means each of the Wi would be equal to 0. So since it is given that each vector V belongs to V has unique representation, and zero vector also belongs to Wi, सारे subspaces में होगा by the property of subspace. So each Wi will be equal to 0. Each Wi will be equal to 0 means summation Aij mu ij or j varies from 1 to mi will be equal to 0, or I varies from 1 to k. Okay, and j varies from 1 to mi. But the vectors in the ordered basis gamma i's are linearly independent because they form the ordered basis for Wi. So all the vectors mu ij's in gamma i's I varies from 1 to k, j varies from 1 to mi are linearly independent. Or linearly independent property say if you put the linear combination of the vectors equal to 0, then all the constants will be equal to 0. This implies all the aij's equal to 0 for all I and j. That means from equation 1, from equation number 1, sum of aij's mu ij's equal to 0 implies all the aij's are equal to 0. This proves that the vectors in the union of gamma i's are linearly independent. Hence, we have shown the two conditions. One is that the vectors in their union generates V. Okay, V को generate करते हैं, as well as जो vectors हैं उनके union में वो linearly independently हैं. इन दोनों property से ये proof हो जाता है कि the vectors the union of ordered bases gamma 1, gamma 2, gamma 3 and gamma k forms an ordered basis for vector space V also. This proves that gamma 1 union gamma 2 union gamma k generate is an ordered basis for V also. Okay. I hope you understand this lecture and the property of direct sum of subspaces, which is a new property that if we are given two conditions, that one is each vector has unique representation, and for each subspace we have some ordered basis, then the union of those ordered bases, one from each subspace, forms the ordered basis for vector space V also. Okay. So if you like this lecture, press the like button and share it. You can also subscribe my channel to get the notification of any other new video on this channel. Thank you very much.